let's jump right into it. So, Ta, what's the first thing we do?
Identify the KSP for the salt that will form.
Sure. Okay. So, what is the KSP for the salt, which is barium sulfate?
1.1 times 10 to the negative 10.
Good, right? Now, the first thing you always do is write your equation, right? So, in this case, kind of two equations we can write, but there is the barium nitrate combining with your sodium sulfate to form your barium sulfate and your sodium nitrate. Well, is this balanced?
No, you needed 2 in front of the.
Good, right. Okay, right. So we've got our reaction here. So straight away, Milith, when you see a question like this where you've been given data about both reagents, what kind of question is it?
You just find the concentration of each to get Q, and then you compare Q to K.
Yeah, good. So yeah, so basically, whenever you've got the data about both reagents, you should all be thinking about limiting excess reagent questions first, right? So that's what I was kind of cueing you all into. In this question, it doesn't matter, and I'll show you why, but usually in a question where you're given data about both reagents, limiting excess reagent is the first thing that should come to your mind, okay? Good. All right, so we've got a V, we've got a C, we've got a V and a C. What do we do, Shashanth, with these values?
You find the moles.
Good, right? So tell me, Shashanth, what is the number of moles of barium nitrate?
So barium nitrate was 0.0051. And
Store that as A. And what is that also equal to, Shashanth? Which ion do we care about?
that's also equal to barium sulfate.
Yeah, I would say not quite, unless you know that's
and also sodium sulfate as well.
I would just say it's equal to barium, right? That's what I was thinking about. The ion we care about is barium and barium sulfate, right? So in barium nitrate, we care about the barium because that barium is going to go and precipitate with the sulfate. So it'd be good to write that down. Good. And what was your value? Who do we have? ARC for sodium sulfate. What do we get?
Oh, so I just did like C1 V1 equals C2 V2. I just found the concentrations of like each like barium and sulfate.
C1 V1 equals C2 V2. What did you use? What did you use as V2?
My V2 was 0.073.
Yeah, look, that works. That also works. So what he's seeing is as a dilution question. Sure, that also works out. Who did it this way? And who got a number of? What did you all get as your number of moles?
0.0046.
0046. Good. We'll store that as B. And Anthony, which ion is this also equal to? Number of
The
moles.
sulfate ion.
Good. That's all we care about, right? Good. Now we should find the new concentrations of barium and sulfate because they're in a beaker and we've added 2 volumes. So the final volume is, as Arik pointed out, 0.73. So we're just going to divide these and get the new concentration of barium and the new concentration of the sulfate, right? So you're going to get A divided by 0.73, B, you're going to divide it by 0.73. I'm not going to ask you for your answer to this. Whatever you got, you should have stored that. And you literally sub that into your KSP equation, right? So this is where you should write the other equation too. So BaSO4 gives you Ba2 plus and SO4 2 minus. Then all you have to do now is A divided by 0.73 times B divided by 0.73. What do we get, Taha? What's your final answer for your... This shouldn't be called ASP, it should just be called QIP, or your ionic product. What do you get?
I accidentally cleared my calculator, so I don't have it.
So shouldn't it be divided by 0.073?
Yes, it's not B, yes. Apologies. So what I've done is a big silly mistake where I didn't add it up. But good. So I would have written 73 times 10 to the power negative 3 because I always do it in scientific notation. You're completely right. 0.073, 0.073. What do we get as our answer?
0.044.
Did everyone get this?
Yeah.
Yeah.
Good, which is bigger than KSP. I've never seen a KSP that big. So therefore, what would you write next? Shashanth?
So since it's less than, since it's bigger than KSP, that means
It's
you'd favor the
0.004. Not
Yeah, it's 4.4 times 10 negative 3 essentially.
extra 0.
Okay, Sure. Double check your calculation work, Ian. Good. All right. So what do we write next? That's my next question.
So
After-
since it's bigger, it'd favor the reverse reaction and that'd form precipitate.
Very good. Reverse reaction favored. I'm looking for one more thing.
Precipitate formed.
Yeah, we've said that. What else? One more thing.
Saturated.
Well, of course it's saturated. It's super saturated, right? Saturation is that point where you either form a mild precipitate, faint precipitate they'll give you in questions, or there's no precipitate. It's super saturated when you form a precipitate. So you want to identify that. Good. And that's full marks. So you would have rounded that off to the correct sig fig. So that would be to 1 sig fig. So you would have written 0.004 rounded off to 1 sig fig. But good job.